All right, how's everyone doing? Mr. Alent here. Gonna talk about some factoring with you guys. Hope you're doing good. I'm trying to give you some more practice with this. I know some of you have struggled with factoring, so let's see if we can make it simple or as simple as we can. I know factoring can be a little bit difficult, but let's see how we do. Remember that when we're factoring, there's really two questions you're going to ask. You're going to first start off with asking, is there a GCF in the polynomial? If there is, you go ahead and factor it out and then move on to question 2. If there isn't, move on to question 2. Question 2 is how many terms do you see? How many terms are there? So if there are 4 terms, that's when you're going to factor by grouping. And we'll see an example of each one of these as we go. If there's 3 terms, that's when we would use that ACB method, we call it. We also call that sometimes that diamond math, where you see the diamond, and on top of the diamond is A times C, on the bottom is B, and you're looking for 2 numbers that multiply to the top number but add to the bottom. Right, it becomes a little puzzle. So we'll do that here in a minute too. Or there could be 2 terms, and with there's 2 terms, there's a couple of possibilities here. You could have what's called a difference of squares, where you have 2 perfect squares subtracted. That's a difference piece. Difference is subtraction, 2 perfect squares subtracted. Or you could have what's called a sum or difference of cubes. So if you've got 2 perfect cubes either being added for sum or subtracted for difference. Alright, and so we'll see an example, like I said, of each one of these, and I'll try to go fast. I don't want to make this too long, but let's see. So for example 1, we are going to factor and find the zeros. I want to remind you how to do that as well. Finding the zeros once you're in factored form of the polynomial. And the polynomial we're going to factor is f of x equals x cubed minus 2x squared minus 9x plus 18. Okay. And so to factor here, we're gonna ask the questions, right? Do we have a GCF? And in this case, we don't, right? If you look at the 4 terms, there's no number that's common to all 4, and there isn't an x in all 4 terms, and so there's no common factor. So we're going to move on to the next piece. How many terms do we see? We see 4 different terms, so we are going to factor by grouping. I'm going to zoom out just a touch here to be able to fit more on. So factoring by grouping. So we're going to group them up, right? And that's when you just kind of pair them off. You look at the first 2 as a pair and the second 2 as a pair, and then really you find the GCF again, but now just of the pairs. And so we're going to factor out from here. The greatest common factor between these 2 terms is an x squared, right? There's at least 2 x's for each. So I'm going to factor it out. Take out an x squared. And remember, when you factor it out, or when I say take out, we're really dividing. We're dividing it out. So x cubed divided by x squared is just an x. Minus 2x squared divided by x squared is just a minus 2. Okay. Then focus on the other group. Looks like 9 would go into both of those. And because there's a negative with that 9, we are going to take the negative 2. We want this x to be positive like that one was. And so take out a negative 9. And again, we're dividing it out. So negative 9x divided by negative 9 is x. 18 divided by negative 9 is a negative 2. And what happens here with this factoring by grouping, and why it's so wonderful, is that we now have 2 new terms. These are big ugly terms, but this is a term, this whole thing, and this whole thing is a term. And there is a factor that's common to both. This x minus 2 is now a greatest common factor between these 2 big ugly terms. And so we factor it out. We're going to factor out the x minus 2, and so then we have to see what's left when we take it out. Well, over here in this term, if I take out the x minus 2, I just have an x squared. And on this term on the right, if I take out an x minus 2, I just have a minus 9. Okay, and so we have it factored, but the question has to be, are we fully factored? Have we finished it all the way? And the answer is no. If I look at this one, right, this is 2 terms, and this is a difference of squares. I've got 2 perfect squares being subtracted. This one's 2 terms, but there's nothing else that can happen here. These aren't perfect squares, they're not cubes. No other factoring can happen. But here, this is a difference of squares. And if you remember, for factoring a difference of squares, right, we still got that x minus 2. You're going to create 2 new factors, and you're going to use the square roots of those. What's the square root of x squared? It's x. So my lead value there, the lead term in each of these binomials will be x. And then the 9, you square root that. Square root of 9 is 3. So my second value, second term in each of those binomials will be 3. And then what happens is the signs are just different. So one's a plus 3 and one's a minus 3. Right? These, if you multiply them out, will get us right back to there. Okay, so that is factored. If we were just asked to factor, we would stop there and say it's all good. But we are going to find the zeros as well. I wanted to remind you how to do that. So to find the zeros, you set it equal to 0. You swap out a 0 for f of x. Because what we're doing when we find the zeros, we're actually looking for x-intercepts. We're looking for where did we cross the x-axis. And when we cross the x-axis, y is 0, right? F of x can be replaced with y in most cases. And so we're saying, okay, when y is 0, whatever we find over here will give us times we cross the x-axis. Well, these three things, this thing, that thing, and that thing, they're multiplying, right? This is multiplication between these parentheses. And the result of that multiplication is 0. That can only happen if something is 0, right? You can't multiply and get 0 unless something was 0 that you multiplied. So the x minus 2 could be the 0, or the x plus 3 could be the 0, or the x minus 3 could be the 0. Right, and we're going to account for all those. And so really these are just now one-step equations. We're solving for x. Go ahead and add 2 to both sides here. You would get x equals 2. Here you would subtract 3 from both sides, so x is a negative 3. Here you would add 3 to both sides, so x is a positive 3. And there we go. So there's our first example. We factored it, and then we found the zeros. Our next example we are going to factor and so we're just going to factor. I've shown you how to find the zeros. We've done it several times. I'm not going to do it again for interest of time. We're going to factor this guy. We got 2x cubed plus 4x squared minus 6x. Okay, and we again ask those questions. Do we have a greatest common factor? And in this case, we do, right? 2 goes into all those numbers. And there's an x available from each that we could factor out. So we are going to factor out a 2x. And then we have to see what's left. Well, 2x cubed divided by 2x is x squared. 4x squared divided by 2x is 2x. And a minus 6x divided by 2x is a minus 3. Okay, so now it is factored, but again, is it fully factored? Well, I see a trinomial here, 3 terms, so we should try, according to our questions, right, the ACB method and see if this trinomial factors nicely or not. Remember, on top, you do a times c. A is a 1 right now, c is negative 3. All right, so a times c, 1 times negative 3 is negative 3. B is 2. All right, b goes on the bottom. And then we're looking for what multiplies to that negative 3 but adds to the 2. And you always focus on the multiplying number. And there's not a lot of things to multiply to 3. It's prime, so just 3 and 1 multiply to 3. But if we're going to have a negative 3, then one of these guys has to be negative. 1 negative and 1 positive to multiply and get a negative. And since this is a positive 2 down here, that means the 3 must be the positive, and it's the 1 that's our negative. Okay, now what these do, why we found those are going to now allow us to factor this. And there's a shortcut here. Right, so a little shortcut. If a is equal to 1, you can apply this shortcut, which is basically those become the pieces of your factorization. Right, so we still have that 2x, but now this piece is going to be factored using the 3 and the minus 1. So an x plus 3 term, or factor, and an x minus 1 factor. And there we go. We are factored. Now, what I want to show you too, though, is what if a wasn't 1? So if a isn't 1, then you cannot use that shortcut, right? If a is not 1, you can't jump right to this using those terms or those values in our factors. So what would you do instead? Well, we still got that 2x there. We're going to rewrite this trinomial. We want to rewrite it as a 4-term polynomial. So how do we do that? We keep the first term and the last term the same. So we keep the x squared. We're going to keep that minus 3, but it's this middle guy, the 2x. We're going to rewrite it. We're going to use these to rewrite it. I'm going to rewrite the 2x as a plus 3x and a minus 1x. and then I still have that minus 3 like I said out there. And this is really still equivalent, right? 3x minus x, that is 2x. But now that I have it in 4 terms, I could then apply our 4-term factoring, and by group them up and factor, I would get back to here either way. Okay, one last example, we'll finish this off. Okay, we are going to factor this function, f of x equals 8x cubed minus 27. Okay, we're going to factor 8x cubed minus 27. All right, now to do this, we're going to have to look at the rules for factoring. This is called a difference of cubes, right? We have 2 terms, right? Go to our questions. GCF, nope, there's no GCF, nothing that goes into 8 and 27. And then we see 2 terms, it's not a difference of squares. The minus means it's a difference, so it could be a difference of cubes, and it is, right? 8 is the cube root of 8 is 2. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So, and then of course x cubed is a perfect cube. So these are both perfect cubes. They're being subtracted. We have what's called a difference of cubes. And the rule for that. Now you have these in your notes. We did those before the school break, right? And so we had a cubed minus b cubed. So if this is our difference of cubes, right? 2 perfect cubes being subtracted. Here's how it factors. You have an a minus b term times a squared plus ab plus b squared. Right, that's how this is going to factor with the difference of cubes. And if you remember, if it was a sum of cubes, how that factored, a cubed plus b cubed, that would be an a plus b times a squared minus ab plus b squared, right? Okay, and so we're dealing with this one up here though, where we've got a difference of cubes, and so what we need to do is look at what are the cube roots of each of these. So what's the cube root of 8x cubed? Well, that's going to be 2x. Right, the cube root of 8 is 2. 2 times 2 times 2 is 8. Cube root of x cubed is x. The cube root of 27 is 3. All right, 3 times 3 times 3 is 27. So for our sake, with this problem, and according to our formula here, these are basically, this is our a, and this is our b. All right, this is a, this is b, according to what we see over here in our formula. And so now we can apply a and b just right into here to get our factorization. So here we go. We've got the a minus b. Okay, so a is 2x minus b is 3 times, then we do a squared, so I'm going to write it out. We're going to do a 2x squared, and then we'll have a plus a, which is 2x, times b, which is 3, and plus a b squared. And now we can just clean that up a little bit. 2x minus 3 times, okay, so 2x squared, that's going to be a 4x squared. 2x times 3 is 6x, and 3 squared is 9. And there we go. We are factored. Now, this trinomial, we could say, well, we need to ask, are we fully factored? This doesn't factor nicely using our ACB method. It doesn't factor nicely at all. If it did, this wouldn't be our formula. We would give a formula that would allow it to go further, but it doesn't. This is as far as we can go as far as ACB. And so how would you get the zeros in this case, right? Well, like before, you'd set it equal to 0. This piece you could set equal to 0. That'd be nice and easy. But this trinomial, you would set it equal to 0, and then you would apply the quadratic formula. And that is how you would get your zeros from this guy. Okay? Hope that helps. Good luck to you guys. Let me know if you have any questions. We'll see you later. Bye.